All right. You're all here for computer science, right? I'm just making sure I'm not in the wrong spot. It's happened before. All right. I'm Dr. Hughes. How many of you are actually first year? Raise your hand. Okay, most of you. How many of you are not first year? Okay, cool. All right, cool. How many of you, is this your first lecture of university? Yeah, nice. All right, cool. All right. So this is Computer Science 161. We assume no knowledge of programming. We assume knowledge of how to use your computer and whatnot, but nothing particularly sophisticated. We assume no knowledge. We start from the basics, and in this course, we learn a lot. And the reason we learn so much in this course is because this course really is introductory. We start from the basics. But we got to learn a lot before you can make it to like the next semester's content, which is where you start to learn more computer science, where this is very introductory. There's a lot to cover before we can actually really start learning computer science. So I'm going to warn you that there's a lot to be learned in this course. But the flip side to that is you're going to learn a lot in this course. People often finish the semester, look back and be like, oh my God, I didn't even know how to do Hello World, and now here I am writing classes in quite sophisticated programs. So don't worry, it's going to be great. It's fun. Just some things. So that's me. My office is in the annex. This is the lecture times. Lecture section 12. This is lecture section 11. Your lecture section 11. Who here knows what lab section they're in? Who here doesn't know the section, but knows when it is? All right, so there's labs. Section 11 is Thursday. Section 12 is Friday. Section 13 is Monday. Section 14 is Tuesday. If you are in lab sections 1 and 2, or sorry, 11 or 12, labs start this week. If you're in lab section 14, which would be today, you do not start lab today. I'm going to say it now because I hear the same thing every year, and in spite of me warning people and giving the exact same thing I'm about to say every year, people still get confused. Labs start, if you're in section 11 or 12, Thursday or Friday, this week. Now, if anyone in here is like, well, hold on, I was just in math, and they said labs don't start till next week. That's your math labs. Not all labs. Mine start this week. So just, I know it's confusing, but labs can start this week. Office hours, these are where they are. That's when you come see me if you need help with anything, right? So if you're working on assignment or maybe after lecture or something, you were a little confused about something, come to my office hours. You don't need to email me or make an appointment. Those are pop-in sessions. The door will be open. You come sit down. We have a chat. All right? And I'm happy to help. Here's the course notes. For all of you that didn't notice, the course content is almost all going to be on this website. I haven't even posted the Moodle one yet. It'll be up. That's where you'll submit your assignments and whatnot. But the course website is CSCI161.com. Okay? It's the course code. CSCI161.com. If you hit enter, though, it'll redirect to this other website. It's just CSCI161 is a little easier to remember. But that's the URL. CSCI161.com. It's the course notes. I record all my lectures, which I hope I am currently doing. Yep, you can't see me, though. And I post the lectures to YouTube, so usually right after class, if not maybe the next day if I forget, it'll be posted to YouTube. So there you go. First thing we're going to cover is just going to quickly go over the outline. It is your responsibility to go over the outline, but I'm very quickly going to go over it. So what are we going to learn? We're going to learn the basics of computer programming. We start with the most simple thing you could possibly do, and we are going to work our way up through more and more complex things. This course is exceptionally accumulative. Meaning, if you don't know what happened yesterday, you're not going to know what's going on today. It's not a type of course where you could be like, you know, the first month I wasn't really paying attention, but next month I'll be good. I'll just pick up and take the hit on the first month's worth of content. Not going to work. Because it's critical to know what happened the first month before you can even think about doing what's in the next month, that type of thing. All right, you got to know how to walk before you can run. There are some disciplines where that's possible. Here, that ain't going to work. It's very accumulative. Do not let this stuff get away from you. Prerequisites, there are none. Me, I'm James Hughes. Lecture section 11, that's you guys. Lab sections, office hours. The website is this website that I'm currently on. Moodle will be used for like your assignment submissions and whatnot. Textbook, there is, first of all, the course notes that are just available on the internet. But there is a textbook that goes with the course as well. It's free. It's just another website, but it's full of a lot more detail than anything I'm going to cover in lecture, because it's lecture. There's only so much time. And there's a lot of exercises in there. And the only way to get good at this stuff is practice. There's no secret. Every year people say like, well, but like, what's the trick? You know, I haven't figured out the trick. Practice. Yeah, but what's really, it's practice. All you got to do is practice. So the lecture notes, some of them, there's some problems, example problems for you to work through, but the course textbook has a lot more examples for you to work through. The difference between someone who like does well in the course versus someone who gets like 99 in the course is someone who actually went through the course textbook. It's easy to do, and you'll be an expert. There's a link to it here, but there's also links at the end of every topic. You'll see. Topics. Intro, variable, types, functions, testing. Who here has any programming experience before? So not a lot of you. I'm actually going to warn you, those that have programming experience, I'm going to warn you. Anecdotally, y'all tend to do worse than those that come in with no experience. Because a lot of people with experience show up, and when we start learning about, like, what's a variable, what's an if statement, what's a type, you're going to think to yourself, yeah, I know it. And maybe you kind of like stop paying attention. And next thing you know, we're talking about stuff. It doesn't take long before we're past your high school computer science course. So don't let the slow wade into the topics trick you into thinking you're comfortable. For those of you with no programming experience, you tend to be okay because it's all new. Everything you need to know, you're just paying attention, you're learning, you're good to go. But if you have programming experience, don't let it get away from you. Don't put yourself into a position where you get like a false sense of security with the topics. That's all I mean. Here's the course evaluations. There's no actual due date set because it really depends on how far along we are in the course. But this is the general idea. Assignment 1 will be due around the end of September. That's usually when it is. Assignment 2, what do I have? Mid-October. Assignment 3, early November. Assignment 4, end of November. And there's 2 tests. One at the end of September-ish and one at the end of October-ish, and then a final exam, of course. Those dates aren't set yet. That'll get figured out once it gets figured out. Again, I don't set it because I kind of want to know how far we're getting before I get that set. If you're looking at this and you're going like, oh man, there's 80% of my final grade is tests. Yeah, it is. But I think I'm really good at writing tests, like making tests, okay? And the way I do it, and you can ask students who've had me before and they'll probably agree, the way I write my tests are, if you know what you're doing, it should be laughably easy. You should get near perfect. If you don't know what you're doing, you're probably going to get as close to 0 as possible. That's kind of like the goal. It's not that I want you to get 0. It's just I want those that don't know anything to not do well because that's how it works. So if you know what you're doing and you see the test and you're going, oh man, no. You just chill. The tests will, if you know what you're doing, should be easy peasy. If you never show up to lecture or labs and don't do anything, well, good luck. Exam, I don't set that. That's the registrar's office, so just you'll get an email at some point in the semester saying, here's when your exams are. Assignments, the instructions on how to submit them will be on each individual assignment. The assignments will be posted to this website. In fact, they're already there. They just don't have a due date yet. You'll submit it to Moodle. There'll be some instructions there. Due dates, they're due when I say they're due. No extensions. No lates accepted. My things are always due at like 11:55 p.m. So, and this tends to shock people, but I don't think it's shocking. If something's due at 11:55 p.m. and you submit it at 11:56, is it late or on time? I think we could probably do better. Is it late or on time? Ah, yes. Why? Because 6 is a bigger number than 5. Right? You've got that. So if you submit it at 11:55, you're okay. But if you submit 11:56, well, that's more than 11:55, therefore it's late. And things that are late don't get marked. You get 0. Simple. There's a weird thing where people go like, come on, it's been 1 minute. And I go like, well, yeah, it's late. You got to draw the line somewhere, right, when something's due. If I accepted something that was at 11:56 and someone else submitted 11:59, I guess I'd have to accept theirs, right? And then someone submits at 12:10 and someone submits at 12:45 and someone submits at 1:30. I mean, where do I draw that line? There's those that are late and those that aren't. So you know what's easier is how about I draw the line at 11:55 when I said it was so you don't have to guess when it is. And you know what would be remarkably unethical and unfair is let's say you submit something at 11:55 and you weren't quite done your assignment. You weren't quite done, and maybe if you had 3 more minutes you actually could have done it. But you were worried, you knew you had to get it submitted, so you submit it, whatever, it is what it is. But someone else takes those 3 minutes, and they submit it late, but I accept theirs. You followed the rules, they didn't. You got punished, though. That's messed up. So it's simple. Hand it in our time or not. After this, every year, someone will email me like, this is unfair, I'm going to the dean. And my response is, well, say hi to Joe. The dean's not going to do anything for you on that one. Marking done by a TA. Tests, yeah, don't cheat. If you miss a test, there's no makeup test, but if you miss a test, the weight of that test will just be shifted to the next test. If you somehow missed both tests, that means you have a final exam worth 80% of your final grade. I mean, I don't recommend that, but more power to you. If you show up for a test, though, you gotta write it. Like if you show up and you look at it and you're like, oh man, I'm going to leave, I don't know this. No, you get 0 on that test. You can't just do that. That's no good. Labs, there's labs every week. The point of the labs are, well, they complement the lecture. During the lecture, there'll be some brief activities, but in the labs, that's where you're actually going to get your hands dirty. And they are semi-instructed. I'll be there. And maybe every once in a while, depending on how things are going, I'll give like a little mini lecture on a topic that maybe some people are struggling on or something. But the point of the lab is actually that's where you get to sit down and actually do with other people around and meet. You are very encouraged in the lab to sit down and work with people. Better way to learn that way, peer teaching and peer learning. Email, yeah, you can email. Office hours, come to office hours. Attendance, yeah, you got to be here. Copyright policy, I own everything in the course unless especially stated. Class recording policy, you're not allowed to record me, but don't worry, I record myself. Post it to YouTube, so you'll be good to go. Don't cheat. We'll check if you're cheating. Tutoring, accommodations, this is all a lot of boilerplate stuff. It's your job to go through the syllabus. A lot of the boilerplate stuff will be common across your courses, so you don't need to be too worried. But there you go. So now let's go through the introduction. So, what are you going to learn in this course? Actually, before we do this, let's stop and ask, are there any questions from anybody before we jump into the topics? Nothing? Okay, it's fine if you don't have any questions right now, but do note, I get really bored if people don't ask questions. So sometimes I'll just pause and wait until people ask questions because it's boring for me. But I won't right now because maybe you have none. So, what are you going to learn? Well, the short version is, well, you're going to learn how to write programs, like actual programs. I don't mean like, oh, I'm a programmer. I mean like, no, by the end of this course, you'll have all the tools in your tool belt of like a programmer. You're going to be a programmer at the end of this course. It's crazy. You learn a lot. You're going to learn how to write programs to solve problems. So it's not just about writing code for the sake of writing code. You write code to solve some problem. You're going to learn a little bit about how a computer works and a little bit about what on earth computer science really is. Because computer science is a heck of a lot more than just programming. Programming is just what we use. Like there's a quote, computer science is as much about programming as telescopes are about astronomy. Like, okay, yeah, you use them, but that's not what it's about, right? Programming, we use it, but that's not what computer science is all about. Now, actually, I want to hang for a moment on that second point, how to write programs to solve problems, is there's a bit of a hidden thing in this statement here, in that right when you identify a problem, knowing there's a problem, and then at the end of the day, if it's been solved with a program, you've got your problem, and you've got your code to solve it. But there's a big gap here. Identifying the problem, understanding the problem, coming up with a way where the program can help you do it, and then actually implementing the algorithm. That right there is the bulk of this course. It's not about the programming. It's about knowing how to programmatically solve these problems. It's a key distinction. This will become clear as we go. The long version, read the outline. All right, so here's a silly little activity. Just chat with each other. Have you ever encountered a computer program before? And can anyone name an area of science or anything where you could think like having skills with programming wouldn't be helpful at all? There's no way it would be helpful. You could take a few minutes, chat amongst yourselves, and just think about this. It's a simple question. Don't worry. Just have a chat. And the room should be loud. I don't want it to be quiet. All right, raise your hand if you've ever not encountered a computer program before. Of course, that was a stupid question. Obviously you have. I mean, even to register for St. FX, you had to encounter with programs all the time. Can anyone think of an area where, like, knowing the skills in computer science aren't going to help you at all? There's no way it's relevant to any particular thing. Can anyone think of anything? Nothing? Really? Every year people try to come up with clever solutions. No? What do you think?
I don't think anything. It feels like a trick question.
I think it kind of is, yeah. It totally is. Right? Because you could always weasel it in somewhere. Well, if I am a Neolithic I don't know, were there Neolithic farmers? I don't know. If I was a Neolithic farmer reenactor, I wouldn't need it. Well, but who schedules all of your things, you know? You're probably going to need it. You know, it's going to pop up anywhere. It's got to. Anything. And it's ubiquitous in your everyday life, right? It's wild to think that when I was younger, like I grew up at a time where cell phones weren't like smartphones. And now, well, you have smartphones. And it's wild to think like how like you've got so much computing power you're like on you at all times. I feel naked when I don't have my phone near me. When I don't know where my phone is, you get that sense of like, oh shit, where is it? Right? So we're so dependent on it, and it's everywhere. And every year that I ask this silly question, it becomes harder and harder and harder to come up with like counter cases because, yeah, it's just more and more ubiquitous in our lives. So what are the prerequisites for this course? Nothing, curiosity. You might be wondering, why are these course notes a website? Well, there's a big reason. One, I like it to be open. I like this content to be available to anybody. It's great. I like that. And you're also going to be writing a lot of code in Python. And when you're writing code, you know, you don't often write everything from scratch. You use existing code that's given to you to help you solve problems. And all of this code, if there's anything you want to learn about Python, for example, you go to the Python documentation. It's a manual, basically, for Python. And it's not a physical one. You go look at it online. And all of the documentation for Python follow this same format as this course website. So it's also to get you used to seeing and learning things from this style. So here's an example. This has like a dark theme, whatever. It's been updated recently-ish. But this is the documentation for a whole bunch of math functions that we might be using sometime. And yeah, it's going to follow the same style as my course notes. So that's also part of the reason why. There are two sections. Now this is wrong. They're actually both taught by me. So I need to update that. But yeah, there's two sections of this course. Section 11, you guys are section 11, and section 12. The only reason for that is, well, it tends to be a big course and not everyone can come in at the one time, so we have the two sections. That's all. How will this class work? Well, it's still a lecture. I'm going to be lecturing for the most part, but there will be some differences in that I'll like to break up the monotony with like activities. Now that first activity, and we're going to have another one here really shortly, they're going to be fairly simple, but as we go in the course, it might be, okay, go see if you can write the code to do this, and then maybe we talk about it a little bit after 4 minutes of you trying it, something. So that's how this will go. That's the plan. And yeah, like I was saying, like those activities are good because there's no other way to learn this stuff than by practice. You can go, like I'll say, like you can go watch every single second of piano tutorials on YouTube that exist. There's probably like millions and millions, if not like billions of seconds worth of piano tutorials on YouTube, right? If you were to watch every single one and I plop you in front of a piano, I say, okay, now play. Do you think you could do it? No. It's the same thing here. People do try to think that maybe by sitting in lecture they'll just understand how all this works by like osmosis or something. I don't understand. You're not going to learn it unless you do it. Practice. People come to me before a test. How do I like prepare for it? Practice. Yeah, but it's practice. Where do I find the problems? Literally anywhere. The course website, the labs. Go Google problems to solve. Think of problems on your own. Just practice. Just practice. That's all you have to do to get good at this. Yeah. So here, let's have another activity real quick. Talk amongst yourselves. Learn a little bit about the people around you if you don't know them yet. What's your majors? Why'd you come here? Why are you taking this class? What do you hope to learn? Etc. Take 2 minutes and have a chat with each other. All right. I realize, like, if a lot of you are in first year, you don't have a major yet, right? Like, you haven't selected it, but you've got an idea of probably what you want. So who here is actually like, yeah, I'm going to do computer science? Raise your hand. Okay, good. That's good. Who here is at least in the Faculty of Science? Raise your hand. Faculty of Arts? One person? Really? What? No. That can't be right. Do that again. Raise your hand if you're Faculty of Arts. Really, just one person? All right, well, you're special. Education? No. Business? Okay, business. Yeah, there you go. What am I forgetting? Nursing? No, nothing. Have I forgotten anybody? No? Okay, since most of you are science, who here is like physics? One person, okay. Oh, two people. Math, stats? Okay, good, cool. Chemistry? No chemists? Where are the chemists? Ah. Biology? One. Sheesh, we've got a really lopsided group here. Who did I forget? H-kin to the science side? One? Yeah, two, okay. Did I miss anybody? All right. All right. Faculty, what's your program then? Computer science, but you're doing faculty arts through. Oh, I got you. Okay, so you only half count. All right. All right, well, that's interesting. I think this is the first year I've had no one from like just another general arts program. Neat. Anyone have any particular reason for taking this course other than like, okay, raise your hand if you took the course because like, well, if I'm computer science, I just got to take the course. Yeah, okay. Raise your hand if you're taking it because you're like, I got to take a course. That looks good. Yeah. Does anyone have any like more compelling reason to take the course? You want to be a software engineer? Yeah. It's a damn good reason to take it, yeah. Kind of got to learn a little programming. No kidding. You'll have a one-up of anybody else in your program, right? Like, well, like the other like 3 business people, 4. No, there was actually a couple of you, right? So you're all making a good call. Smart move. Anybody else? Anything else interesting? No? Well, hopefully throughout, over the semester you discover maybe why you're really compelled to take the course. Anyone taking it because they heard really bad things about me and they just wanted to see for themselves? No? One person, 2 people? Yeah, sounds about right. All right, so what do you bring to class? Well, realistically, you don't have to bring anything to class other than yourself. Although, obviously, I'm recording lectures, posting them on YouTube, and the course content is this website that can be accessed by anybody. Obviously, that content's available to you, but I still highly recommend taking notes of things that you hear and whatnot. It's been empirically shown that actually taking notes helps retention and learning a lot better than just sitting and listening. You don't have to, but by all means, if you can, bring a laptop. You do not need to. But if you've got your laptop handy, and we've got some programming exercises, or maybe not, but we're doing something you kind of want to follow along and try stuff, yeah, do that. I highly encourage it. You don't have to, though. It's fine. But you might find some value in that. Now for a question a lot of people want to know. Is this class easy? Well, this is a tricky one. So the way I like to put it is, look, knowing the individual tools is easy. Raise your hand if you know how to use a hammer. Of course you do. Raise your hand if you know how to use a screwdriver. Of course you do. It's a stupid question. Of course you do. But just because you know how to use the individual tools doesn't mean you know how to build a house from scratch, right? It's a little more complicated than just like, oh, I know how to use a hammer and a saw and a screwdriver. I could go build a house. Well, maybe you know how to use all those individual tools, but you don't know how to put them together and use them the right way together to go solve this bigger problem. So the individual pieces, people tend to find relatively simple to understand. That doesn't mean they're trivial, but a little simpler than using them to solve problems. So this is often a struggle people have, and it always comes from a place of just not practicing. We're going to learn about variables, types, if statements, loops, functions. And you might know how to do all of those individual things. You might be like, yeah, I know how those all work. I get it. But I just don't know. I just can't. As soon as you give me that problem, I don't know what to do. Yeah, because you've got to practice. The individual things that we learn are a lot more simple than actually putting things together to solve a problem. So in that's where the difficulty comes. This course is, you got to practice. It's very accumulative. So if you're not on top of it, you're going to fall behind and you might get left behind. And just as a warning, this is not me saying this is a hard course. Just as a warning, intro programming, regardless of the university you're at, tends to have a shockingly high fail rate because it's not simple. If you're expecting it to be easy, here's what I will say. I'm not going to say it's hard, but I will absolutely say if you're taking this course because you think maybe it's going to be easy, no, it's not. You picked poorly. I'm not trying to scare anybody at all. All I'm trying to say is, we're here to learn this stuff, so let's learn this stuff. Practice. Stay on top of it. You'll be fine. What else did I want to make sure I hit here? I record the lectures. I think I do a pretty good job with the lectures too. There's labs, there's office hours. There's all of these tools available to you. There's student help hours that they run. There's also these general tutorial hours they have in the annex every once in a while. There's a lot of tools made available to you for you to succeed. But I can't make you learn anything. Who's your teacher? Point to your teacher. Some people are right, some people are wrong. I ain't your teacher. I'm the prof. I talk at you. I can't make you learn anything. You got to teach yourselves. I'm really not the teacher. That's not how this works. I'm not responsible really for teaching you anything. I want you to. I want you to learn things. But you got to be teaching yourself this stuff. That's all. That's the best I can do. We give you all of the tools that we can for you to be successful, and you got to take those tools to make yourself successful. And here's the thing too, if you've never taken a physics class before, I'm going to pick on physics, and this is not necessarily the best analogy, but I'm going to use it. If I've never taken a physics class before, but maybe I've taken math and chemistry classes, and I show up to physics, I'm going to have a lot of transferable skills with what I've learned in other courses. What I've learned in other subjects, I can show up and probably hit the ground running in physics because it's not going to be too wild versus what I'm used to in other things. Computer science tends to be a little different in that a lot of people have no experience with it, and there's a lot of content, there's a lot of courses out there that have nothing, like, there's like very few transferable skills from other courses. The best you could do is like algebra. Good algebra experience is good prep for this. Other than that, you probably don't have a lot of background. Math is helpful, don't get me wrong, but you probably don't have a lot of transferable skills relative to how you would in other disciplines. So that's another reason people tend to struggle off the start, because it is different. But I do want you to succeed, no matter how pessimistic I sound. I really do. So how to get good at it? Practice, read, stay on top of the content. Go through the course textbook thing, go work through the problems. If you go through all of the exercises in the textbook, which probably wouldn't even take very long at all, you'll crush this course. It'll be laughably easy to you. If you just show up and kind of do your thing, if you show up, you get your assignments working, you submit it and whatnot, you might still fail this course. You really got to be on top of this stuff. Should you be terrified? No, absolutely not. It's entirely doable. It just takes the effort. That's really it. I'm not trying to scare you. I'm just making sure you have a good understanding of this is different than what you're used to. It's a doable warning, though. This class is dense and very cumulative. Don't fall behind. The good news is you get to make mistakes. Actually, so this is the awesome thing. To me, this is the best thing about programming. And this is going to sound weird, but it's the best thing. You are going to be wrong all of the time until you're right. That's what programming is. You write code, it doesn't work. You write code, it doesn't work. You write more code and it doesn't work. You change it, it doesn't work. You try to fix it, it doesn't work. Then you realize, oh, I didn't do this, and you change it and it still doesn't work. And then you do a little bit more and then, oh, suddenly it works. Hey, great. You're going to be wrong all of the time. This is another thing people get hung up on when learning programming. If you're not used to making mistakes, see, I think I was lucky. Back in my day, I grew up with like Super Mario Brothers. That game was bullshit. Shit was hard. It ain't like today. Games hold your hands. You kids got it easy these days. I learned that you suck at this game until you beat it. And even then, you just beat it. It doesn't mean you were good at it. You fail so much. Who here likes Dark Souls? Ever played Dark Souls? Really? Oh, only a few people. You suck at it until you're good. You fail, and you try again, and you try again, and you try again, and you try again, and then you succeed. That's programming. In all the movies, you see people sitting down going, oh yeah, I'm coding. Doesn't happen. Coding happens like one letter at a time where people are scratching and pulling their hair out. And then they hit run and it doesn't work. And then watch that scene over and over for 25 minutes, and then finally something works, and then there you go. So when people are sitting down working on their assignments, and they're like, oh my God, it's not working. I'm terrible at this. No, that's exactly how this goes. You're going to be wrong every time before you're right. But here's the best part, is it's math, and you're doing your math assignment, and you come up with your solution, you submit it, and you're like, I hope it's right. With programming, it's different. You know if you're wrong or right before you even submit your assignments. How do you know? Because I say, write a program to do X, Y, Z. You write it, you run it, and if it does X, Y, Z, great. You get to be wrong. Not a lot of courses are you allowed to be wrong. You get to be wrong a lot here. You just keep being wrong until you're right. You are going to be making mistakes the overwhelming majority of the time. And that's not because you're new. That's because that's programming. That's what it is. I'm not being silly. That's what it is. There's some like statistics about like how many lines of code do software engineers actually write a day. I don't remember the number. I think it was like literally like 20 lines a day or some BS like that because it's so low because they're doing thinking and they're planning and they're making mistakes and they're trying things and whatnot. That's programming. In the movies with the hackers, that ain't programming. That's laughably unrealistic. You're going to make mistakes a lot. You get to see what you did. You get to see if what you did worked or not. Yeah. What happens if I do this? Run. Oh, that didn't work. Great. That's another question I get a lot. It's like, can you do this? You can ask me that. Or you could just literally try it and see what happens. When you write code on your computer, you're not going to break your computer. The computer won't give a shit. In fact, when we're running code in this class, we're not even going to be running the code on our computers. We're going to be running it on Google's computers for free. So even if somehow magically you figured out how to blow up a computer with your code, which you're really not going to do, if you did, it's not even going to be your computer. It's going to be Google's. So you can make as many mistakes as you want. It doesn't matter. Try things. This can't possibly work, right? Hit run. Did it? Maybe it did. Probably didn't. Who knows? Try it. Not many classes give you this luxury. I can't stress it enough. Most of the time when you're working on the course material, you're going to be wrong. The majority of programming is actually what you call debugging. Writing code is easy. Writing correct code ain't. Get used to making mistakes. This is a good thing. This is normal. This is to be expected. Get used to being wrong. Get used to failing and failing and failing until you get it right. I need help. So here's another thing. I saw this comic years back and I really liked it. Life before Google. Here, it's kind of hard to see. Let me zoom out. I really like it because it's true. If there's anything you want to know more about, you can do it. I'm really stuck. How do I do this? Type it into Google. See what happens. You'll find an answer. How do I do a loop in Python again? Let's see. I don't remember. How to do loop in Python. Oh my God, look at that. There's literally 116 million results that are all probably pretty relevant. It's become a bit of a joke in this course where, all he does is tell you to Google things. Yeah. You can ask me a question, and sometimes I can answer it. Sometimes I can't. Sometimes I can, but I don't want to, because I'm an asshole, I guess. I don't know. But I'll tell you, Google it. Not because I'm an asshole, but because if half of programming is debugging, the other half is Googling it. That's not a joke. That's how you write code. Is you write a little bit of wrong code. Maybe you Google the bugs you're getting. Maybe you forget how to do X, Y, Z, so you look it up. Does a package exist to do this? How do I do that? You'll find the answer. This independent learning, if you look at computer science pedagogy, and pedagogy is just a fancy word for the theory of teaching. If you look at computer science theory of teaching, one of the number one things they try to emphasize is independent learning. Literally telling students to Google it. So when I'm telling you, look it up, sometimes maybe I legit don't know the answer. Sometimes I'm just trying to get you to the skill of doing it. Sometimes I get emails from students at 10 p.m. writing a giant-ass email that I'm not going to read. And I'll respond with, I don't know, did you Google it? And then every once in a while, when I'm feeling really spicy, someone asks me a question that could have really been answered with Google in 2 seconds, and I'll reply with a link to Google being like, come on, get it together. You could have figured this one out. It's not because I'm an asshole. I mean, sure I am. But it's because learning to find these solutions on your own is the other half of programming. That's not a joke. You can go Google, just Google it, programming memes. You'll find a bunch. Right? They're just everywhere. The internet's been really slow today. Right? It's just everywhere. There's one of my favorites is like doctor. Wait, is this it? Doctors. Yeah, I like this one. Because yeah, that's the other half of programming. It's just Googling it. Now, people will often ask, though, like, well, hold on, now I'm worried about cheating. Like, if I Googled it and found a solution to a problem, that's only really going to happen with some of the elementary stuff that we're learning. As soon as you start solving more complex problems, you're really not going to find a solution to your problem. You might find solutions to subproblems, because that's the thing with programming. When you're writing code to solve problems, you end up writing like little pieces to incrementally work towards solving the bigger problem. So you might find solutions to some of the subproblems, or maybe you find a solution to a subproblem that's very similar to yours but not quite right, and you take it and you change it to do what you need to do. No, that's a good thing. That's code refactoring. That's a really good thing. Modifying things, and that's a good thing because it means that you understand your problem, you understand what their problem is, you understand that what they did and how it works for their problem, and you understand how to change what they did to make it work for your problem. That's a good thing. So getting used to looking these things up and just kind of like, how do I do this? And throw it into Google, you'll save yourself a lot of time than writing me a giant email at 10 p.m. because you will find the answer. Now, I need help. Okay, yeah. Obviously, I don't mean don't come to office hours. Obviously, I don't mean don't come to lecture. I mean, try Googling it, come to office hours, come to lecture, watch the lecture recordings, go to the labs, go to the help sessions that the students put on, go to the general tutorial sessions, whatever. There's a lot of resources made available for you to be successful. It's in your hands, though. And why did I say Google so much? Well, when programmer isn't debugging, they're Googling. It's a joke that it's so common. I'm going to tell you to Google it. I'm doing that intentionally. Independent learning is one of the most important things you'll learn. Further, it's just a generally useful tool. Get used to Googling it. What's this one? Oh, that's a link to a video of someone saying one of the best skills you can learn in programming is how to Google things. Now, if you've got your laptop, did anyone read this by chance, this link on the website yet? Did they find it? Probably not. There is a link on the website near the bottom of the table of contents, Getting Started. Long story short, what it's going to tell you to do is go to Google and type Collab. It'll say, hey, welcome to Collaboratory. You click it. You might get some landing page like this, and you might need to go File New or something. But eventually, you'll get to a page that looks like this. I have the dark theme. Yours might have the light theme. But you'll get to something that looks like this. This is Google Colab. This is where we're going to be writing our code for this course. The reason we're using Colab is it requires no setup. If you've got a Google account, you have access to Colab. If you don't have a Google account and you hate Google and you never want to do it, well, we could come up with an alternative, but my suggestion, it's going to be easier to just make a Google account for this course and use Colab. This is where we're going to write our code. This is a fully operational Python notebook. It's a fancy way of saying this is where we're going to write our code. It's possible. We could do it locally on our own computers. We can. It's just a little bit more of a pain in the ass to set up. If you want to do it, by all means, sky's the limit. I don't care. Great, that's good. But Colab is what we're going to use. It's the simplest. It's easy peasy. Good to go. Has anyone used this before? One person? Cool. All right, that's where we're going to use it. So go to Google Colab, and here's what we're going to do. We're going to write our first program. If you're there, raise your hand if you're there. If you're looking at a page like this. Raise your hand if you'll be looking at a page like this if I give you 20 more seconds. Okay, I'll give you 20 more seconds. And this is where we'll end. We're going to write our first program. It's Hello World. All it is saying print Hello World. Hello World is traditionally the first program a programmer writes, so that's what we're going to do. It's a really simple program. We're going to tell the computer, print this message out. It might seem silly because we're saying print this, and you hit run, and then it just does that. But that's a program. So I'm here. I'm typing print. Note, I did not type the 1. The 1 is just there because it's a line number. So I type print, open parentheses, quote, hello world. Then I hit run, hello world. There. If you did it, you just wrote a program. I'm not being silly, that's a program. You've done it. It's a simple one, sure, but it's a program. And we'll pick up here next time.